Think of this, if you're cleaning piping and you have food in a tank or you have valuable product in other lines, you certainly can't get cleaning fluid in that product. It destroys the product. It could be a safety issue if you did it and didn't know, because cleaning chemicals are pretty aggressive. Dangerous, certainly something you couldn't eat. So a lot of care was always taken to separate cleaning fluid from product. And for a long time, how that was done is you just ran product until you were ready to clean. And then you finished running product, you stopped and cleaned. So that was you were pretty confident you hadn't gotten cleaning fluid over into a batch of product because they just weren't even in the area at the same time. Then you did start to have a need to clean maybe piping systems or a certain tank or something while you still had some production going on. It's a little bit of efficiency in that you could have a batch being started while you were still cleaning maybe some piping that product was going to go through. So how did you separate that? The way it really was done for a long time was very definitive breaks in the piping, and an easy way to do that was a transfer panel. And they get called a lot of different things: jumper panel, CIP panel, U-bend panel, flow panel, flow plate. There are tons of different names. Most people in the industry understand regardless which one of those names you use. And they were just a very definitive, this jumper, that it is clearly hooking that pipe to this pipe and not to this one. And that gave the ability to very confidently say food's going through here, cleaning fluids are going through there, things are completely separate. Those panels could have proximity switches or something on them that were also telling the control system that these are hooked up. That gave you a nice ability to maybe make sure a pump didn't come on when it wasn't supposed to or something like that. But there's some downsides with that. One, it is very manual. If you want to make a change, a person has to go out there and do things. Unhook, take clamps apart. Sometimes it takes two people. Move a jumper, reclamp it. Maybe they got it in the right spot, maybe they didn't. It just took time, and so you didn't want to do it very often, even though there are some processes where you do it fairly often. And you were kind of limited. If a jumper didn't go from one place to another, you either had to go make one or change piping or something like that. How those plants were operating is they were trying to run as long as they could and then clean, and they still a lot of times would end up with a lot of the plant shut down and not operating while they were cleaning. From time perspective, for sure. In some instances, could be a less fluid situation, but generally it's time. You're saving time by moving to, and time savings can be thought of in a couple of ways. One, you just are spending less time making changes to get ready to clean. The other side of that is you're not having to shut down things that aren't being cleaned in that moment, so they're allowed to just keep producing. Think of it this way: if you have a factory and it's running and 8 hours a day, it has to be down, and the factory is at capacity and sales are better than the capacity of that factory, then you get in a situation where a business may need to start looking at capital investment to construct a new facility or additional process. That could mean hundreds of millions of dollars of capital expense. Or if you could take your existing factory and suddenly you get those 8 hours of production in the same building, with the same staff and the same basic infrastructure, now you have almost a third more production out of the same building. It's that much longer before you have to go spend hundreds of millions of dollars building a new facility. This is not just a with equipment thing, it's understanding. People tend to be more scared of things they don't understand. And so I may start with just a Mixproof valve that has a side cut out of it and really start explaining, here's what's happening inside of this valve. Here's how it doesn't mix. Here's how, if parts of it fail, how it still doesn't mix. Like I mentioned earlier, it's amazing design effort has gone into these and a lot of thought, and very foolproof. Even if the elastomers, the rubber that does the final sealing, even if they're gone, the valve is still designed not to mix. Careful language there too, mix proof. It's not leak proof. They will leak, things go wrong, but they're real good about when it goes wrong, it puts it out the bottom to the floor, which tells everybody, hey, there's something going wrong here that needs some attention. They won't mix products from one chamber to the other. I've found once folks kind of understand that, start to see how it mechanically works, and we go into those details, then they start becoming a lot more comfortable with the valve itself, it being in their plant, how it's going to work.